Seagrasses are often called coastal canaries, and that's because they're sensitive to environmental change. One of the biggest drivers of seagrass loss are too many nutrients in the water column. So how do I get too many nutrients in the water column? It tends to be things like fertilizer runoff from agricultural fields or from lawns. It can be inadequate sewer systems or septic tanks. Those nutrients get into the water. Algae can take up those nutrients, and if there's a large algal biomass taking up those nutrients, then it limits the light that reaches the bottom. Seagrasses are rooted plants, so if there's not enough light reaching the bottom, they can't photosynthesize and they'll die.
Another source of damage to seagrasses in Florida is propeller scarring. We have a lot of shallow water seagrasses in Florida. We have a lot of tourists in Florida, especially down in South Florida where we have lots of shallow water seagrasses. So prop scar damage can be a considerable impact to seagrasses.
So there are a lot of direct impacts to seagrass beds in Florida, and they include vessel strikes and groundings and prop scars. They also include development activities. Historically, dredge and fill was a major source of impacts to seagrasses. And a lot of that coastal development has fallen under pretty strict permitting laws, and that's reduced a lot of those direct impacts. But there still are marinas that are built and docks that are put up, and these things either dredge seagrasses out or shade them over time. So there are still direct impacts to seagrasses. But far and away the largest threat to seagrass ecosystems in Florida and worldwide are declines in water quality.
One of the big difficulties with seagrass restoration is that once seagrass disappears, you get a negative feedback. And what that means is negative things happen when seagrasses are lost. Nutrients that were stored in seagrasses are released and they're in the water column, so those problems with eutrophication, with algal blooms, they happen when seagrasses disappear. Seagrasses hold sediments in place, and when seagrasses aren't there, then wave energy can resuspend those sediments, and again, there's not a lot of light. So that negative feedback means that once seagrasses are lost, you no longer have a good habitat for seagrasses. So you have to come up with innovative ways to get seagrasses to survive or clean up a lot of those problems before seagrass restoration starts.
There are two main ways to restore seagrasses. One is to eliminate the cause of seagrass loss and let seagrasses recover on their own. And the other is to physically transplant seagrasses. By far and away, the biggest bang for your buck is to eliminate the source of seagrass decline and let seagrasses recover on their own. Usually the source of decline is reduction in water clarity from nutrient-associated impacts, phytoplankton blooms, that kind of thing. When I started in the lab in the mid-1980s, the question was then is, can you really effectively restore seagrass? And it was focused primarily on technique development. And what we found over that time is you can use almost any different kind of transplanting technique. Site selection is the most limiting factor, since reductions in water clarity are usually the biggest reason that we have seagrass loss. It's very difficult to find large areas to transplant seagrasses to make any kind of a difference at an ecosystem level. So my philosophy has changed over the years. It used to be, can we transplant seagrass, to where I am now, which is, should we transplant seagrass? And I think the answer is, there are occasions when you should transplant seagrass, but by and large, we in the state of Florida and elsewhere would be much better off by using whatever funding is available for habitat restoration to restore water quality, and that way it will lead to much larger scale additions of seagrass over time.
The most effective way to mitigate these damages is to do things to reduce the nutrient pollution and the suspended sediments that are reaching our estuaries. And that can be done by moving communities to sewer, by updating stormwater systems, and limiting the amount of fertilizer, say, that are put in residential areas, particularly during the wet season. Now, more directly, ways to restore seagrasses are often associated with direct transplant of plants from areas that have grass to areas that do not have grass. And they can be rather difficult to do and problematic in terms of their success rate, but they are often the only thing we can do when there are direct impacts, often permanent impacts to seagrass beds.
One of those small-scale problems are prop scars, so where boats have interacted with the bottom and created a gap or a trench in the seagrass meadows. A lot of times what happens is this goes below the root zone of seagrasses. And so the problem is seagrasses are really good at growing up, they're really good at growing sideways, but they're not really good at growing down.
Now, a situation where you really do need a good technique for restoring seagrass are vessel groundings, large-scale vessel damage from eroded prop scars and that sort of damage. So where we focused our research, and I've been working with folks from NOAA over the last 15 years to look at this question is, what are the best ways to repair what we call blowholes, or areas that were impacted by either prop scars that eroded or by vessels that grounded and have created deep holes in the seagrass meadow that can't recover on their own. So for the last few years, we've been focusing on repairing vessel damage, primarily in South Florida, but these techniques can be applied anywhere. First, you bring them almost to grade with what we call pea rock, which is just really small limestone rubble. And then on top of the limestone rubble, we have something called sediment tubes, and they are just biodegradable fabric tubes that are filled with fine sediments, which seagrasses prefer. And you lay those tubes on top of the pea rock, where it's totally up to grade, to make it the same elevation as the adjacent seagrass meadows. And then another interesting thing that Judd Kenworthy actually developed is the use of bird stakes. And they're really very simple. They're nothing more than PVC poles with a block of wood on the top of them that's big enough for a bird to sit on. And we arrange them throughout the injury we're trying to repair. And what happens is birds sit on these bird roosting posts and they poop. And this bird guano is really good fertilizer in areas that are phosphorus limited. If you have plenty of phosphorus in your water, you don't need bird stakes. But in areas that are phosphorus limited, like many of those in the Florida Keys, they add the nutrients that really can accelerate seagrass colonization.
And once that topographic restoration has taken place, once the sediments have been filled up to grade, then we'll transplant seagrasses from what we call donor beds. And oftentimes we'll select fast-growing seagrass species like Haliduli radii to try to jumpstart a successional process from these faster-growing species like Haliduli and some of the Halophilas to slower-growing species like Syringodium and Thalassia that are often thought of as the climax species in these subtropical beds, but are more difficult to plant and grow much more slowly. So the best monitoring protocols, or most thorough monitoring protocols, will often revisit a month or two after transplanting to check on the survival of the planting units to see whether those transplanted grasses have taken, so to speak. And if they're not, oftentimes you'll have supplemental plantings, or you will make a change to the site, to adding more fill to bring it up to grade and then replant. Because we found that one of the more critical periods for a restoration effort is in those first couple years. That transplanted grass really does need to take hold, obviously, before it can expand and fill in the site. And then over time, the focus then shifts to whether or not you're achieving percent covers that are comparable to adjacent beds. So that entails placing out transects and quadrats and counting grass in cells and quadrats or estimating percent cover visually. And during that time, you're often doing this at the species level. So you're trying to understand whether or not the restored bed is at this same species diversity, say, as adjacent meadows. And then over time, the hope is that restored bed will achieve percent covers and community composition in terms of seagrasses, but also in terms of attached macroalgae that are comparable to adjacent areas.
We restore seagrasses initially because we value the functions and the services that they provide. They hold nutrients in place, they hold sediments in place and keep the water column nice and clear. They act as a habitat for commercially and recreationally important fisheries. So how do we determine if our restoration is successful? We determine it by determining if those functions and those services of our restored plots are similar to a normally functioning seagrass, or if we picked a service or had a reason for our restoration if that particular service has come back. So we can do water quality monitoring inside of those seagrass meadows. We can do fish seines or collect invertebrates and see how animals are using those systems.
So how long does it take for a restoration effort to achieve success, for the climax species, for a dense thalassia bed to develop? Under ideal circumstances, if you're planting an earlier successional species like haliduli, it can take about 3 to 5 years for that haliduli to reach acceptable density over your restoration site. That can be shortened some if you're adding fertilizer. And oftentimes this is done with bird stakes. So these are roosting stakes that cormorants and other coastal birds will sit on, and their excrement adds fertilizer to the system. It can help haliduli grow a bit faster. For a transition to thalassia and the development of thalassia bed, you're often looking at between 6 and 10 years, but there are some restoration sites that are more than 15 years old that still haven't achieved densities of thalassia comparable to adjacent seagrass beds. So active seagrass restoration is construction of these planting units and moving them from donor beds to recipient beds and putting them in the ground is a real labor-intensive process. And it often requires a lot of hands if your aim is to do a large enough area. And there's often a push to do a large area because it'll help mitigate the risk that the site as a whole will succeed, right? So in order to get those hands, it's often a good idea to include the community. You get community buy-in and exposure to the habitat. They get to touch and feel the resource that they often just look and see as it goes by them underneath the boat. And it gets them talking about the value of the ecosystem services that seagrass habitats provide. And they get a great experience. Putting together planting units and snorkeling around and putting them in the ground, and they have ownership over a bed that they help save.
So the choices that Floridians make every day can impact the coastal ocean health and seagrass health. One of the biggest drivers of seagrass decline are too many nutrients in the water column. How does the average Floridian impact the number of nutrients or the amount of nutrients in the water column? There's a couple ways. One way is through septic systems. So if you're on septic, making sure that the systems are running optimally is really important. Another is how much fertilizer you're putting on your lawn. If you put too much fertilizer on your lawn, it's not going to help your plants. A lot of that is going to run off. It's going to end up in the coastal ocean. So using the right amount of fertilizer is important. The amount of that ends up in the coastal ocean has to do a lot with how your municipality is treating your wastewater or your stormwater. So another way that Floridians can impact seagrass health is by being politically active or electing officials who value and provide resources for nutrient issues.
Seagrass restoration is quite possible, but it's labor intensive and expensive. And the best thing we can do in Florida is to prevent seagrass loss in the first place and to improve water quality so we don't continue to lose seagrasses, and hopefully we can bring back seagrasses into the system that were lost from reduced water clarity.
Seagrass restoration is really difficult. There's often failures. and it's really expensive, and so sometimes people think it's not worth investing in. However, those ecosystem functions and those ecosystem services that seagrass provide and then a return through restoration are really valuable. They're valuable to economies, they're valuable to adjacent ecosystems. And when we get it right, that return on investment is really high.